And number two, we've got two computer science students, graduates from Heritage. Two computer science students graduate from Heritage and both come to you to manage their investments. Graduate A begins saving $300 at the end of each 6-month period immediately after graduating in an account that earns 4% interest compounded semi-annually and continues to pay into that account for 25 years. After 25 years, Graduate A decides to stop contributing to the fund and leaves the money in the account for an additional 10 years. So a total investment period of 35 years. Graduate B deposits a lump sum of $5,000, which was a graduation gift from his rich uncle, and begins saving $150 at the end of each 6-month period in an account that earns 4% interest compounded semi-annually. He continues to pay into that account until he retires 35 years later. So which graduate will have more money when he retires, how much more, and why? And then we are asked to describe why the investor who ended up with more money did, and what characteristics of the investment caused that to happen. So this is probably going to take me a couple pages to do, so I'm going to do Graduate A on this page. And then I'll do Graduate B on the next one and finish things off there. So this graduate begins saving $300 at the end of each 6-month period immediately after graduating. So we're going to swing our Surmton. And our periodic payment is going to be $300. The rate is 4%. Not a very good rate. Anyway, he's doing this at the end of every 6 months, so it's going to be 2 compounding periods per year. And he's putting into this account for 25 years. So our R over M is going to be 0.04 over 2. So that's going to be 0.02. And MT is going to be 2 times 25, so 50. Pardon my momentary pause there. I had to go find my formulas. And so this is a fund that we are paying, that this person is paying into. It is growing, so this is going to be a future value of an annuity. And so we will have our formula S equals R times 1 plus I to the power of n minus 1 over I. And what we're going to end up with here is we're going to throw our information in there. So we got S equals 300 times 1 plus I is 0.02 to the power of n, which is 50, minus 1 over 0.02. And so back to Wolfram. Paste my formula in. And the payment each month is going to be $300. I is going to be 0.02. And N is 50. And so this person is going to end up with $25,373 in this account. So S equals 25,373.82. So this annuity grows to be worth $25,373.82. And so I was pausing for a moment because I was thinking, man, that's not very much. And then I realized that he's only making these contributions semi-annually, not monthly. And so not a huge amount going into the account, so you can't expect a gigantic amount coming back out. And anyway, continuing with this graduate's story, the graduate stops contributing to the fund and leaves the money in the account for an additional 10 years. And so Now that we have stopped making contributions, this is no longer an annuity. It's just going to grow by compound interest. And so we've got S. Surmton again. Okay. And we have an initial value, so a starting value of 25,373.82. Our rate is still 4%. It's still going to get compounded semi-annually. It's going to be in there for 10 years. So our R over M is going to be the same that it was before. 1.02. And MT is going to be 2 times 10. That's going to be 20. So what we've got for compound interest is S equals R times 1 plus I to the power of N. And so S is going to be equal to $25,373.82 times 1 plus 0.02 to the power of 20. So back to Wolfram again. We've got S equals 25,373.82 times 1 plus 0.02 power of 20. And so this grows to 37,704.16. So the ending balance is 37,704.16. Okay, and that's not a huge amount of money. Again, because this graduate only put money in the account semi-annually, and so you can't expect $300 to turn into $1 million if you're only putting it in the account twice a year. So with that, let's go ahead and move over to the second graduate and take a look at their situation as well. So I went ahead and got graduate B set up for us. And so we can see the graduate B deposits a lump sum of $5,000 into an account. And so that's going to grow by compound interest because it is a lump sum. So we'll get going with that one, the $5,000. Everything else is the same as it is for graduate A. So the rate is 0.04. It's going to be compounded semi-annually. And this money is going to be left in the account until he retires 35 years later. So our R over M is 0.04 over 2. So 0.02. And MT is going to be 2 times 35, so 70. And so compound interest formula is S equals R times 1 plus I to the power of N. So S equals 5,000 times 1 plus 0.02 to the power of 70. And so let's see what we got. $5,000 times 1 plus 0.02 to the power of 70. And so that $5,000 does pretty good. It turns into almost 20 grand just by sitting there doing nothing. So S is going to be 19,997.79. And so the lump sum grows to a value of $19,997.79. So in addition to that, this graduate put some money away semi-annually, just like the graduate A did, except this graduate only saves $150 each month, or not each month, each 6-month period. So twice a year, he's only putting $150 in the account. As you can imagine, that's probably not going to do a whole lot. So we've got $150 going into an account. The rate is again 0.04. M is 2. And he is doing that for how long? Continues to pay into the account until he retires 35 years later. So he continues to do that as well. So that's going to be 35 years. And the R over M is going to be 0.04 over 2. So 0.02. And MT is going to be 2 times 35. So 70. And so this is a future value of an annuity because the value is going up. So our formula for that looks like S equals R times 1 plus I to the power of n minus 1 over I. And so back in Wolfram, paste that in there. And we're going to have S equals 150 times 1 plus I is 0.02 to the power of n is 70 minus 1 over 0.02. And so our R is 150. I've got 0.02. N is going to be 70. And 0.02. 22,496 is what we end up with. .69. Okay. And so the annuity portion of this grows to a value of 22,496.69. Total value is going to be the compound interest that was the $5,000 that grew to 19,000 and something plus the 22,496. So total value is whatever 19,997.79 plus 22,496.69 is. And so I'll get Wolfram to do that for me real quick. 22,496.69 plus 19,997.79. And we get a value of 42,494. .48. And so it looks like graduate B ends up with quite a bit more money by about $5,000 or so. So over here we had with graduate A a total value in this account of $37,704. And for graduate B, we had $42,494. And so it's interesting that graduate B only ended up about $5,000 ahead. And that's the amount that he put in the beginning of the gift from his rich uncle. And the other things that were different between these two things were that graduate A put $300 away every 6 months. Graduate B only did $150. And so it doesn't take a huge sum of money like $5,000 to start doing this, everyone. The intent or the idea is that you just start with whatever you can, and it will eventually grow to be hopefully a huge amount of money for you. And so grad B ended up with more money. The $5,000 gift really helped. So that $5,000 by itself grew to almost $20,000. If graduate B had only been working from the annuity, he would have ended up with just 22,496 and would have got surpassed by about $15,000 by graduate A. So just again, another little lesson in doesn't matter how much you can save, but start saving and do it now.